All right, so today we have experts in the fields of AI and data science, Peter Norvig and Alfred Spector, who are also a part of the group of authors behind one of my favorite new books, Data Science in Context. And I will place a link in the episode notes along with a discount code. Make sure you get this book. It is going to be a great guide for data and AI teams, not just the technical people in these teams, but basically anyone building data and AI products. So first, in your book, data science is the study of extracting value from data as insights or conclusions. And it's also, you describe it as transdisciplinary, which is great. So first question to you folks is, so you list statistics, OR, which is great. No one talks about operations research, computing, and ethics. What about, what's your guys' take on UX and visualization? Because in the early days of data science, people talked about data products, which always meant some great nifty interactive UX. So where does who's responsible for UX and visualization? Is that another group of people?
I think that's a great question, and I just got through teaching a class at Stanford on human-computer interaction and AI, and so I think for AI and data science, we want to build products, and like any product, making it useful for the user and having the right user interface is important. I think with data science, I guess we sort of thought of it as statistics has the visualizations covered. And if anything, statistics was kind of more towards visualizations, whereas machine learning was more towards just getting the right answer.
Right. So we did definitely think about the importance of visualization, Ben, because it's just incredibly powerful in helping people achieve insight from data. And I was first really became crystal clear to me when I looked at this thing that I think was called the baby name wizard or something like that, which was just so fascinating to see how the popularity of baby names goes up and down over the years. And it required a dynamic interface. It had some graphing. It did some completion based upon the initial prefix of the name. This is back circa 2000, 2002, something like that. And just very powerful. So we mentioned that, and we would have put a lot of pictures in of great visualizations, but almost all of them are dynamic, and they actually don't work in a book. So I think it sort of originally comes out of the statistical realm. That's where the first visualizations were done, of graphing and all sorts of things. But I think it's a critical component of what we have here. Just as Peter said, when you want to build something for people, you use visualization so much of the time.
Yeah, and as Peter mentioned, HCI, it just reminded me of one of my favorite data products, which is Google Translate, which a lot of people may not realize, but you can actually correct the translation inside. So they place this UX element, which makes the product better over time.
Yeah.
And it's data driven, and it's entirely data driven, right? That's the thing. We call that an application of the transformation aspect of data science, right? You're transforming one language into another, as you would also if you're doing speech reco. You're doing transformation of an audio signal into a textual form that's in some coded system.
So when I got the book from your publishers, I before I opened it, why did they write another book on data science? There's a lot of books on data science, right? But then when I opened it, I was really pleasantly surprised. So what is the origin story behind the book, and who was the target audience?
So the real origin story is that I had to give a talk at a conference, and the other keynote speaker was Michael Jordan, who is really smart and knowledgeable. And I felt under immense pressure to say something interesting since he was the other keynote. So Michael is a professor at Berkeley in machine learning and statistics and all manner of creative things. So it put a lot of pressure on me. So I initially wanted to talk about what it took when you are really working with data to do something well, and what the risks are if you don't do it well. And I think that came out of probably the work that both Peter and I did at Google, when we saw that it isn't just so obvious how to use data to turn that into a good search result, a good recommendation, a good advertisement, or all the other things you can do with data. So that's kind of the origin story of when the idea happened. And then it's a ton of work that Peter and Chris and Jeanette and I did to turn this into something more than a 30 or 40-minute keynote speech.
Yeah. So Alfred had the talk, and it was well received. He came to me and the other co-authors and said, "Let's turn it into a book." And I said, "Oh, great! It'll only be a couple of weeks' work. We'll wrap it all up quickly." And the scope rapidly expanded, and it, as usual, took a lot more time than we thought. But hopefully, the end result is worth it.
Yeah, if I can say something about Peter, though, that's really interesting, is when Peter said, "Yeah, I'll do this," he said, "I'll really learn a lot about what data science is. That's a good reason to go write a book." So I can say to all of your community that may listen to this, if you want to really learn something, go write the book.
And it is a book that can be read by anyone who works in data and AI. I mean, not just the people who are hands-on, but actually, I think a good audience for this book is product managers, right?
Yeah, I think that's right. I think that was our aim. And like you said, there's lots of other books that have formulas and math and code in them, and we didn't want to duplicate that because there's many other options out there. But we wanted to talk about some of the principles behind it at a level that, as you said, is right for a product manager, not necessarily a technical person. But we also wanted the technical people to know these are the kinds of things you should know, right? You can't just know the algorithms. You also have to know the societal implications and the ethics and so on.
Right. So I guess if you thought about it, there could be three different kinds of ways the book could be useful to people. So one is people that are data scientists or engineers getting the background level of information about the breadth of what they're doing. So that might not have been quite as important, say, to an engineer if you were building a payroll system, because it's hard to get the specs exactly right, but they're not going to be controversial. Here, the complexity of the application and the requirements and all the other issues, the privacy and security, all that stuff is much more complex. So seeing that perspective is necessary. Second is, and another thing Peter really actually called out in one of the sections in the book is, I think some members of the general public need to understand some of the things that are in this. And the reason is that we're deluged with data, we're deluged by recommendations and deluged by conclusions that members of the press use based on data. We should understand a little bit about the benefits and limitations of that. And we make some recommendations to the general public. And then I think finally, I think it's certainly the case that policymakers should understand sort of the limits and complexity of what they're trying to do as they try to do policy or law or things of that form.
One of the great things about this book is you folks have this analysis rubric, which is a good set of criteria for anyone embarking on a new data science project. So can you give a brief description of the analysis rubric?
I'll give it a try, and then Peter can fill in the color. So what we thought about is that there are some implementation-oriented issues you need to think about when you're going to undertake a data science project. And we divided them up into three sets. So one is, do you have the data, right? Is it okay to have the data? Can you get the data? Will it have the necessary integrity, quality, et cetera? And think about those issues. And they're not so simple. Second is there a technical approach to generating a conclusion from the data? So is the situation one where there's some stationarity and you can make predictions, or is it going to be something where it's so game theoretic it's going to be hard to reach a conclusion? If you have certain aspects of the system that are require absolute precision, will the model be able to achieve that? So is there a model effectively? A third is, and we had some debate over this, but we finally concluded you have to think about the issues that comprise dependability. It doesn't make sense to start a project which won't meet certain dependability criteria. So privacy, will people be able to depend upon those guarantees that we need to make? Security, will the system operate correctly, and will it not go down? Will it return the right results? Will it be free from abuse? We've seen so many systems that get put up that get abused by people for whatever reasons, bad actors for different reasons. And then finally, will it be sufficiently resilient, given that we know, right, that things don't always go exactly as planned. So those are the three implementation-oriented ones. Before I go on, Peter, would you add anything to that on the implementation side, or?
No, I think that's good. I mean, I guess I should say at the start, I was a little bit of a skeptic of the idea of a rubric. Maybe I'm more of a bottom-up type of person, and my view was sort of, well, every project is different, so there isn't one answer to all projects. And I guess maybe I tried to say, well, can I disprove this rubric? And said, let's look at a range of different problems and see how they go. And eventually we decided, we can put this into the rubric. We can make the rubric broad enough that it covers a wide range of different projects. So I was happy at where we ended up at the end. And I guess I wanted to say, like, as Alfred said, this idea of safety and trust is important and has to be built in from the start. And I think that's one of the biggest lessons of the book. And I think in some places we haven't quite learned that, right? And so, like, we have this distinct field called AI safety. And that just seems wrong to me, that it should be a separate field. It's like, as if the civil engineers had one field for bridge building and another field for bridges that don't fall down. Right, we don't separate those out, and so everybody should be concerned with safety from the start.
By the way, as I was reading this, one of the questions I had in my mind is, what is the best way to operationalize this rubric? Is it like a checklist? Is it a, do you log on to a thing and I'm about to start a data science project? Here's the elements. What would be the best way to actually operationalize this? And there's benefits, by the way, to doing that, because you have automatic documentation, right?
Right. So Peter, you're going to say?
Yeah, I like checklists. I like what Atul Gawande wrote about checklists and how they're effective. I think so. That's true at the start. You should be thinking about that. And I think throughout the project, you have to sort of institutionalize, we're going to have these various types of reviews at various points, pre-launch and post-mortem and everything else. And there's going to be a privacy review, and there's going to be a safety review, and there's going to be a fairness review, and so on. And so, just making that a part of the whole workflow.
Makes sense, right? And so let's get back to that. Let's go through the rest of the rubric. Mm-hmm. So they're requirements-oriented elements. So the others were implementation, right? We had data, is there a technical approach, and can you hit some key dependability issues? Then if you think about requirements, we broke that down into three categories as well. So one is understandability. So we know this is one of the challenges, right? We often can get a conclusion out of a computer system that's using data, but do we know why it's made that? Do we have any explainability or interpretability of it? Second is, a lot of the times we'd like to know causality. We'd like to show causality, and that's frequently very difficult, if not normally very difficult to go do. But it's extremely important when we're trying to use data to develop public policy or understand science or healthcare decisions. And then finally, very importantly, we've begun to see that more is as data is used in science to develop conclusions, can you reproduce the results so that other people can check them? And that's hard. You saw, for example, when DeepMind produced its protein folding code, they weren't able to release the code right away because it was so much work to package it all up, the data, all of the algorithms and techniques. It was really an ensemble of different techniques they were using. It's very expensive to go do, and they're a relatively big and rich organization. So it's very hard to go make things. So understandability is, to what extent do we need that? And it's critically important as we're using these systems in more and more life and death situations. Second is, do we really know the objectives? So it's one thing to say we want a recommendation system, but what does that mean, right? Are we trying to have news that's balanced across different dimensions? What dimensions are they? How much information should be presented to people that they might not be interested in, just so that you show some dispersion of results, et cetera. And we go on with that in almost every discipline, even in route finding, which I thought would be one of the most obvious ones. Even there now, you're trying to minimize time or minimize tolls or maximize fuel economy or not disturb people on side roads or perhaps even maximize safety by not going on roads that are more dangerous. So really tricky to get the right objectives right. And then what we emphasize because of kind of the probabilistic nature of data science is make sure you have an application that's tolerant of the failures that are probably likely to occur. And that makes certain things that we did initially with data science, say advertising, pretty good, right? Those are good application. If you get the wrong advertising recommendation, as long as it's not too bad, it's probably fine. On the other hand, self-driving cars, that's a really challenging use of this. So those are the requirements one. And then the final seventh one is this general question of how do you balance what are often conflicting requirements, or conflicting goals rather. So and maybe requirements, so privacy versus security or benefits to one group versus another group. So there are ethical considerations, there are legal issues. This is, as you've discussed in one of your recent podcasts, Ben, there's so many laws now governing all of this. This is no longer the unregulated industry of computing that it was 10 or 20 years ago. And then broadly, what's going to happen socially because of all this? As what are the effects on humanity? What are the effects on competition, et cetera? So that's what we think about in this rubric. Obviously, you can't get everything done up front exactly, right? You don't know every answer. It's not a waterfall method that Peter and I would by any means suggest. But I think at the beginning, you should think at least somewhat about all the issues. And then as you get through the project, you iterate and go back and look at things, and just like in any software.
So this kind of so Peter, do you think this kind of goes towards injecting some software engineering rigor into data science? You know, if you think of data science, traditionally a lot of it is actually data work, right? So building pipelines and making sure they don't break. And actually, there's a lot of data engineers who have spent a lot of time the last couple of years injecting rigor into how they build pipelines. So is this kind of similar? This rubric can inject some rigor into how you build data products.
Yeah, I think that's right. And I think there has been some of that lack of rigor. So, you know, a lot of people doing data science are not software engineers. They're statisticians or they're scientists, and they've kind of, you know, picked up a little bit of here's how I use this API, or here's how I use this notebook.
Or what's a unit test?
Yeah, right. So not having unit tests, not having version control, and so on. And you know, I've talked to people and said, "Oh, well, here's your paper you published. How do you know where this chart came from?" And they say, "Oh, yeah, you know, this chart. It's called output final data dot really final dot JPEG, and you know that's my chain of provenance." And
Or
But
dot really, really final.
Yeah.
if you start using elements of this rubric, then you get towards closer to.
Yeah, right. Then you start saying, right. So, I mean, it's a way for people who maybe aren't trained as software engineers to say, here's why we have all these processes, because we've made a lot of bugs and we've noticed where they are, and we've made tools to help mitigate those. And so this is maybe an introduction to putting a little bit more process to make sure things are more likely to be correct.
Which generally, Alfred, the data scientists don't like, right? So they want to be able to move fast and just build their model, hand it to someone, and then move on to the next thing.
Well, so that gets into the word context that's in the title. In some contexts, that might be fine, right? If you're like, going experimenting with some game and you're trying to build a bot to play the game, go ahead, have fun. It's probably pretty safe, doesn't have to be perfect, and that's fine. On the other hand, if you're trying to reach a conclusion about, the efficacy of a drug or vaccines, or you're trying to actually, deal with some of the societal issues now, like, recidivism in courts and such things, that's just unacceptable, right? It's just completely unacceptable. We can't do it that way. So I think there was a time in the early 2000s, maybe, when all this data became available, like we were thrilled if you could get a good result in many cases, right? So like, look at that, it's predictive. And then as it became important, you realized, oh, well, we know we can get that sort of a result. Can we get a good result?
Yeah. And so Peter, one of your classic essays that you wrote with some other people is this unreasonable effectiveness of data, right?
Right.
So in many ways that still holds, right?
Yeah, and maybe it holds even more, right? So we're seeing these large language models now doing things that back when I wrote that article, we never would have imagined would work.
So the reason I bring it up is then, do I still focus mostly on data, getting data?
I mean, I guess to me, it's, we've seen a progression of the field. Computer science was sort of founded on the idea that it's all about algorithms. And then in writing that paper, we wanted to say that for some of the things you want to do, focusing on the data is more important than tweaking the algorithm. And I think now we've progressed another half decade or whatever, and now I think maybe more of the focus is on saying, yeah, okay, you got the algorithms, you've got the data. What you really should be thinking about now is, do you have the right objective function? Are you optimizing the right thing? And don't just take the objective function as given. Examine, are you being fair? Are you preserving privacy? Are you making the right trade-offs between false positives and false negatives? And it seems like that's where a lot of the attention should be now.
So I think, Alfred, what we need is for the rubric is some sort of series of it's like a checklist, so that as Peter described, so that when we kick off a project, then we can bring all the stakeholders in the room and kind of go through the rubric. This is what we're gonna do. And
you want me to? I don't know whether can I share a screen for a second?
Sure. Yeah.
Okay.
Yeah. Oh, wait. Let me give you.
You'll have to enable me and trust me here.
Yeah. Let me do that here.
Of course, I have to share the right screen here too. Okay, I think I see it. So this is sort of a page from the book that you probably see, right?
Yeah.
So it shows that there is a rubric, right? There's this table says these are the 7 things at the top that you heard me and Peter describe: tractable data, etc., all the way through ethical, legal, and societal considerations. Then we break that down further. So there is a rubric, and I think it has to be adapted to different organizations based upon the kinds of things they do. And we'll see whether tools get built for that, or it just becomes part of a gestalt or something of that form. So we'll have to see as time goes on. But I think it does make sense to think about this at different stages. In particular, Peter and I are both teaching. When you're with really bright Stanford or MIT students, sort of the overwhelming thing many of them want to go do is, I want to go build a machine learning model, right? What's the model? Exactly how many layers of the network and what exact details and how do I get the perfect? That's a piece of it. That's great. It's great they're learning that. That's really important. We've been amazed at how successful that has been, and it most certainly has been. It's indescribably powerful now. But there are all these other things. And the bulk of the work, as you know, in your work and all the people you talk with, is often associated with the rest of this now. So we have to make sure our students see that breadth of necessity.
By the way, Peter, Alfred mentioned regulations, and next year I think a lot of data and AI teams will get caught flat-footed because there's a bunch of regulations coming online. The EU AI Act, I find that now is more like October next year, but it's coming. New York, April, or thereabouts. But when I talk to my friends at this law firm that specializes in AI and analytics, their one piece of advice is improve your documentation at this stage. And so I think this rubric, actually, if you implement it, then you have all these artifacts and documentation, and you're in better shape than most other teams.
Yeah, I think that's right. And I think one of the target audiences for the book is people that have to deal with these legal implications, lawmakers and lawyers and so on. And I guess one of the ways I think about it is that in our legal system, we sort of have two ways of deciding what's right. So one is we write laws and regulations when we sort of clearly feel we know what's right and what's wrong, and then you have to obey that. But sometimes it's hard to do that. And instead, we rely on case law, saying, we can't precisely say where the boundaries are of what's okay and what's not. But here we have some case law that says, in this case, this is good, and in this other case, this is bad. And I think we're going to have to be like that going forward. That it's too hard to write down ahead of time exactly where the boundaries are of what's okay and what's not, because the technology is moving so fast. So we're going to have to rely on these sort of case examples of here's an example of the kind of thing that's okay and the kind of thing that's not.
So Alfred, you mentioned that most of your students, they get excited about models, right? So how do you get them excited about the other stuff?
Well, I think these days people are very interested in issues of fairness, right? That comes out of both mathematical, computational, data science topics, as well as out of political topics that are currently being thought about heavily. So I think people are interested in that topic. I think it's easy to go in, and they're also interested in privacy, right? Because there's been an awful lot of computer scientists that have paid a lot of attention to privacy. But they've often been sort of narrowly discussed. What I think it's important, what I try to do at least, is to say, look, these are two examples of a number of different things that come up as you look at this, and let's generalize from that to all of the issues that we have. And I think students do find that interesting. I'll just give you an example. Like, I was teaching in the spring of this year, a mostly graduate course, and it's just when DALL-E came out. And I had a woman in my class who's very artistic, and she was on that right away. And I hadn't really thought much about the issues of intellectual property protection. It's not exactly violating copyright using DALL-E, at least in my opinion, but it is learning an enormous amount about artistic styles. And does there need to be sui generis protection? That got a really interesting debate in the class, because that was new to everyone at the time. So people are seeing things that they can get their arms around. And I think if we can explain these, Ben Fried called this sort of the extrinsics of data science. And because a lot of these things aren't the model or the core data, but all the stuff around it. I think people are realizing maybe that's where the action's going to be now. for a while.
But also, Peter, to some extent, or to a large extent, the machine learning community is driven by benchmarks and beating benchmarks, and you make your name by beating a benchmark or something like that, right? So all the incentives point towards models. Am I misrepresenting?
I think that in the academic community, that's somewhat true. That we've said you get to write a new paper if you come up with a new algorithm that beats a benchmark. I think in the commercial community, people care about offering a product that is a good value for the consumers, and it doesn't matter if it's a new algorithm or putting together old.
Yeah. To some extent, what's the most famous recommendation engine right now? It's TikToks, right? So we don't even know the researchers behind it, right? So
right.
Yeah. So one of the topics I wanted to talk to you guys about is you have your rubric, but then now we're seeing a lot of developments that point towards more and more automation. So what parts of the rubric will I be able to automate in 2 years?
Recursion, the oldest trick in the book. Apply recursion here.
So the building of the model, I think we're close. Even set aside the code generation thing, the auto ML kind of tools, right? So if I have the right data, maybe I can have an auto ML tool that comes up with kind of a good enough starter model, right? So what else?
So look, people are looking at, on the data side, right? They're looking at all manner of automated data transformations and such things, right? To try to go and generate code from English language queries or whatever to munge the data. So that's progressing along with whatever other software, automated software tools. I think that's similar. The other ones, I'd like to sort of quote Peter, though, on objectives. In a recent piece that was published by MIT, he said that, data provides, I'm going to quote you, Peter, if I can, data provides evidence, not answers. To make use of data, you need a rough model of what's going on in the world. Given the rough model and the data, the process of data science can fill in the details of the model in the way that's most consistent with the evidence. But without the model, the dating's meaningless. We can use the resulting model to suggest actions, but we first have to tell it what our preferences are. So it's that last sentence that I want to get to. So that talks about how do you get the right objectives. I don't know how easy it is to generate those, right? Those are a tricky thing. We have political elections trying to generate some of these things, or Supreme Court rulings, or rulings by regulatory commissions in the European Union, and debates between nation states. So I think some of these things actually don't lend themselves to automation in the same way that the creation of the model, or perhaps the
right. So the data, the creation of the model, then there's kind of the data quality checks, data munging. What about, Peter, some of the other aspects like transparency and understandability? Are we developing tools to make those easier to do?
I think right now there are more research type tools. I don't think there's something that you can incorporate into the workflow very easily.
But is the trend towards that also getting automated?
Yeah. I think it's recognized that that's an important problem, and we have to build ways to deal with that.
Look, in terms of reproducibility, that's a software engineering topic to a large extent. So if we really versioned every set of data that we ever used, and we versioned every library precisely, and every sub-library and sub-sub-library, and we knew exactly what code we had used to produce a particular conclusion or graph or table or something, one would think that could become easier to do. So that's a matter of engineering, that once things become more stable, I guess that one sounds like that one's pretty obvious. Now, on the other hand, causality in that one, what we have people that are doing research in the area are doing is trying to reduce the cost of additional experimentation by creating the likely causal factor.
Right.
But the ability to completely automate it, I think, is kind of hard.
Yeah.
Where do you guys fall under? What do you guys think of synthetic data?
I think it's necessary for a lot of the applications we have now. In some places it's really easy to do. So places where you have a good model, like in computer vision, you can take one image and you can change the lighting and you can crop it in various ways and so on, and that's great. I think we'll have more tools for that. I guess I wish if we understood better what these models were doing, maybe we wouldn't have to do that. Right?
And also if the simulator is so good, then you spend all your time building the simulator, basically. So it reminded me of what Alfred was just saying, right? So what if I could kind of simulate these experiments so I don't even need to run them?
Right. And I think that's a place where we're seeing very different degrees of success depending on how well you can simulate something, right? So, like in self-driving cars, it's like the first 1,000,000 miles are always the hardest. You have to drive the cars on the road, and then you have a pretty good simulator, and then the next 1,000,000,000 miles you can drive in the simulator. I've been trying to work in education and trying to apply machine learning to get students to better results. And there we have no simulator whatsoever of what a student's going to do. And so if you want 2 years worth of data, you got to run an experiment for 2 years, and there's no way around that. And progress will be a lot faster if we had such a model.
So
and I think in finance, it's also a challenge as well, Ben.
Yeah.
So it's hard to figure out how to get synthetic data in these very game theoretic financial systems.
Right. So here's a risk that I think about. I don't know if I'm kind of overthinking it, but the software supply chain, right? So I'm looking at studies which say that the attacks on PyPi, the Python software supply chain, grew 41% in 2022. And yet the entire ML and data science community is built on Python. And by the way, if you install a Python library and you look at your screen, it's installing so many other libraries, right? So no one is taking a look at that as far as I can tell. But since you folks worked at big companies with a lot of security people and stuff, is that something to actually worry about, the Python software supply chain?
Yeah, I think so. I think we're vulnerable to attacks, and you see reports of that all the time, of malware sneaking in various places. And it's true for these Python libraries. It's true in all the app stores and places like that. But
Python in particular, Peter, because of the ML, right?
Yeah,
people in ML only use Python.
Right. I don't know if Python's particularly good or bad.
Right.
I think Alfred and I are fortunate that we've worked at big companies that can afford to kind of have their own custom system that's been very well vetted. I think a smaller company starting up, like you say, says, well, I don't have the time to
or everyone is using
for
this
everything, so
I'll just install it, right?
I'll just install this thing and 1,000 things will load and I won't even know what's being loaded. So yeah, I think that's an issue. And I think there's room for vendors to provide things, and you see that in things like Anaconda that says we're going to wrap up all these packages, so hopefully you only have to install one thing, and we could outsource the vetting of sub packages to vendors like that.
I think it's a broader problem, I think, than just Python. I think that's the feeling you'd probably get from Peter and me. It's just a general issue with this system where we have so many layers of abstraction that are composed, and exactly what's being used 12 levels below some routine is very hard for people to know. And there's risk, even within a really big company, when there was a horrible security flaw 10 years ago in some core library that was it SSL or something like that? I think that's
Right.
what it was. It required packages everywhere to be recompiled at all sorts of levels because it hit everything.
Or what if you can plant a backdoor into NumPy or?
Yeah, so I mean, all these things are risky, and I think as we use our systems for ever more important things, we have to take that context of risk into account. What I wonder will happen, no one knows how it'll play out, though, is that we're moving more towards a lot of the stuff being run in cloud environments. So the cloud vendors, just like, say, IBM mainframe did in the past, may actually be the integration point for a lot of things, where a lot of things get tested and integrated. And that might prove to be a way of making things more secure. That's a little bit far afield from data science, and just sort of a prediction, though, that the cloud world, to me, looks a lot like what the IBM mainframe world looked like to me when I was at IBM many years ago.
So I want to actually take the time to ask you guys about language models and what people. I actually don't like the term foundation models, but let's use it. So foundation models and language models. So if you look at the list of all of these models on paper, there's a lot of them, but the number of providers is actually in the single digits, I think. Only a few organizations actually are building these models. They just have the multiple versions, like you have GPT 1, 2, 3, and now 4, right? So, and so on and so forth. So do you think that in the future that companies will just depend on a few providers for these language models, or are we starting to get to the point where maybe some people can produce versions in open source or their own private language models? Because imagine if you're like in a big company like a bank or a healthcare chain, and do you really want to depend on one of these language models trained on public internet data? So anyway, speculate. How will this field evolve? Yeah.
I guess the issue is that it's expensive to build these things, and that will evolve over time. It'll get cheaper as we get more specialized hardware. We've definitely been going in that direction, but it'll get more expensive as people say, well, now that I have more hardware, I want to make them even bigger. And so who gets to build them will depend on how you can amortize that cost over the intended use. And the easiest way to do that is for a large cloud provider that has lots of customers, and so that will continue to be a big use case. A company in a business that also has a lot of customers can afford to build their own, and that may be done at several levels. They may start with a off-the-shelf model and then tune it or
actually, Peter, even regions like the EU may build their own. Right?
Yeah. I think it's likely there will be specialized models that deal with the confidential information that governments or other institutions have that are incorporated into the base model. And it may be that they're able to somehow or other subclass a even more universal model and do that. But I think it's quite clear that has to happen over time.
Yeah, the other issue, I guess, Peter, is for the most part, you only have API access. So now you're talking about a real opaque black box, right? So API access, and then they can, who knows, they can change the terms of service, they can change the API. You may need features that they don't have. So I think I'm starting to think that people may want more control over these things.
Yeah, I think that's right. I think there's a trade-off of convenience versus control, and there's always issues of cost, and I think there'll be different offerings at different points on those trade-offs.
Yeah, yeah.
In a way, we're already seeing it already. I mean, the biggest question, right, when we use, Chat GPT or something like that is, where's the data from? And is the answer right? So there's no footnote on every sentence from it saying, here's the basis for this sentence. And that issue of that lack of transparency, which I don't think we know how to solve at the moment, I could be wrong. I don't think we know how to do that. Is a substantive issue as we look at deploying this in certain situations. Is certainly value. There's no doubt it's a creative value from these models, but use of them in certain domains is going to require, I think, more specialization and maybe some breakthroughs still. I don't know what you think, Peter.
So in closing, both of you are teaching now. So in 5 years, what do you think you'll be teaching if you're still teaching data science? So what do data scientists need to know in 5 years?
I guess we'll need a new edition of the book in 5 years.
But the problems are continuing to change. Peter said that our problems will be, good examples for 2 or 3 years. And after that, or maybe not even, we'll have to add new examples.
But a data scientist may no longer need to code.
Yeah, I think that's right. And I've always you get these pushes to say everyone should learn to code, and I think that's the wrong way to talk about it. Right? Everyone should learn to solve problems and be able to reason with appropriate models. And one way to solve problems is through code, but it's really not that important how much the code you write yourself versus how much you can call upon and use in appropriate ways. And I think that's the skill that's going to be important.
So do you still need to know, in 5 years from now, you may not need to code much, much less, but do you still need to know stats and machine learning? And I mean, to what extent do you need to know these things? Because can't you just go to Chat GPT version 11 and ask them what is
No. So I think that people clearly need to have some understanding of the mathematics of statistics and probability and such things, just for perspective. One of the things we make, just on the point of the general public, whenever the general public sees a number in an article in the newspaper, do they have the denominator? So 7 things of this form happened. Out of how many? I wish there was a code of ethics in journalism that you had to put the denominator in for everything. So I think that's a sort of simple example, but there's so many things of this form that I think the statistics and that sort of thing, everybody needs to know. And they need to understand the other conundrums that occur as you look at data and conclusions and insight. And
but if you look at a data science or AI team 5 years from now, you might need less people who know the details of ML and stats, and more people who know about the domain and the business problems and the data sources. Am I?
Yeah, I think less people who know the algorithms, but everybody involved has to know how to interpret results.
Right. I agree with that. So we do make we don't make a lot of policy recommendations in the book, but one of the ones we do, and we did think about it, is we would emphasize teaching more statistics and related subjects even in high school, right, to kids. We don't need to get only to the public that goes to college. We need to get to much more of society.
So something's got to give, though, Alfred. Is it calculus? That's
I resisted this for years, Ben. So, for many, many years, I would have said, oh, it's the most wonderful thing I ever learned. Sir Isaac Newton, what a beautiful set of models. It's like, I don't know if you can see my hand on my heart here, but it's like, yes, I would reduce some of the calculus time and probably some of the trig time.
I agree with that. I think, we teach calculus for several reasons. One is because it's a useful tool in a lot of the sciences, and also because it's a kind of reasoning, right? So, in arithmetic, you just apply the algorithm, but when you're trying to solve an integral, you have to think, and there's various approaches you can use, and you can say, okay, I'm going to use integration by parts, and I have to follow through these steps, and then I'm going to get to the answer. And that process of planning a result and following it through, I think that's really important. And we should continue to teach that, but we don't have to teach it in calculus. We can now say, just go to Wolfram Alpha and type the integral in, and it will show you all the steps. And, that's just as automated as multiplying two 5-digit numbers. So, I want people to understand sort of the ideas of how calculus works and how change works and how we can analyze that. But I don't think they have to learn all the tricks for all the ways to do integrals. I think we can take that time away and teach some other type of problem-solving skill.
Right, and I think we can do some of that with coding. I mean, whether everyone needs to do coding on a regular basis to solve a data science problem or not, which was the discussion you were leading, Ben, previously, I think, and many believe that the notion of doing some programming does teach a kind of logical thinking. It teaches a kind of way of creating models, of executing those models, which are now algorithmic models. And that's becoming clearly more important as time has gone on and computers have become so, frankly, magnificent.
Right. And I think also, I remember in my introduction to calculus, it was like, well, think of it as sums of the heights of these histograms. But of course, you would never try to add up that sum because that would take forever to do the addition. So it's much easier to learn these formulas. And now that's wrong. It's much easier to add up the histograms to whatever precision you want.
Peter, my introduction to programming in Math 1 in college was they had us program doing integration.
Yeah.
That was like, so I wouldn't be in this field if it weren't for the fact that it was a computational approach to doing this that we could use back in 1972.
Yeah.
So in 5 years, how much coding will software engineers still be doing?
Look, there's a continuum here. Already, when I was CTO of 2 Sigma, we hired people that were super good at algorithms and super good at, at reasoning about code and all these things. And sometimes the interns would come to me and say, "Why are you requiring us to have done so well in MIT's 6046 class or the equivalent, which is sort of an advanced algorithms class for undergrads? Why do we need to know that? What we're really doing is integrating things." And people said that. I'm sure that's true at the big tech companies as well, is that that's a lot of what you do. So the field's been moving towards the integration of components for a very long time. So I think what we're doing is by teaching some of our students, not all, but some of them, to be really good at thinking through algorithms and really good at understanding, the details of programming languages and type systems and all that stuff. What we're really doing is ensuring that they have the intuition and the reasoning capacity to assemble things well. Now, will that change more? Probably. But I do think there's value. I mean, maybe I'm just an old timer, and I am an old timer, but perhaps there's value in learning that so you understand how the big things fit together. But you will be obviously you'll be doing less and less programming of the details than when Peter and I started out, when we did all the details initially.
Yeah, I think, different people have to work at different levels. Cassie Kassaroff has this nice analogy that she says, if you were opening up a restaurant, the first thing you would do would not be to say, well, I really need a PhD in stove design from MIT. You can let somebody else design your stove, and you just need a chef who's used a stove before. And so I think we'll see a lot of that most people will say, I don't need these algorithm designers. I need people with experience using the tools. And then some smaller number of people will still have to invent the new tools and so on. But for most people, it's just you use what's available.
And with that, thank you, Alfred and Peter.
Thank you, Ben.
Thank you, Ben. And thanks for the recommendation for the book. We appreciate it.
Yes, and make sure you check the episode notes. I have a link to the book.